Hi everyone, welcome to the channel. In today's video, we're going to be looking at matrices and determinants. So we're going to look at what is a determinant and how to calculate it. So a matrix is basically the sum of the products of the elements within the matrix. So if we look at, say, a 2 by 2 matrix. So say I have a matrix A, and that matrix is 3, 1, 4, and 10, right? The determinant is just a number. So we write determinant of A, and then we do these square lines like this. And that is going to be equal to, if we do a cross like this, right? 3 times 10, and then we take these two, and that's going to be minus, this is plus, minus 4 times 1, and that is going to equal to, what is that? That's 30 minus 4, which means it is going to be 26. So the determinant of this 2 by 2 square matrix is going to be 26. So now let's look at a 3 by 3 matrix. And before I go to an example, let me write down what a general one would be. So now I'm going to choose A to be a different one. Right, and I'm just going to start off immediately with the determinant of A. And I say A11, A12, A13, A21, because I want to just show you what it's going to look like in general. So I use the notation for the elements in general. Okay, and what we're going to do is we're going to take the first row and use what we call cofactors and minors in order to find out what the determinant is. So I'm going to start with A11. Let me circle it, A11, right? So the minor of A11, right? This is how we figure out what the minor is. We take A11 and we put a line through everything down the column and everything down the row. Then whatever we're left with, that is your minor. Going to be A22, A23, A32, and A33. Right. We're going to need also the minor of A12. So A12, I'm going to use blue, that blue there, and you put everything through the row and everything through the column, right? Which means the minor in this case is going to be A21, A23, right? Everywhere where there isn't a blue line through it, and A33. And then the last one we need is going to be the, it's missing an R, the minor of A13, right? And I'm going to do that one in yellow. So if I circle A13, put a line through the column, line through the row, everything that is not covered in yellow is part of that minor. So that is going to be A21, A22, A31, and A32. Right? Right? So then the determinant of A is going to be A11 times the minor of A11 plus A12 times the minor of A12 plus A13 and the minor of A13. Okay, now you see here I've said plus, but the signs are actually not just addition, right? You remember when we did the 2 by 2 matrix, it depended on the direction that you're going in. So you see here it was plus, but this one is minus. So the way that's determined is if you have a matrix, right? Say we've got a matrix and we're going to use the matrix A. The signs are going to be plus, minus, plus, minus, plus, minus, plus, minus, plus. You see the diagonals are always plus. Okay, so this would be for a 3 by 3 matrix, right? So that means that the determinant of A that I've got here, this must be a minus sign, right? So that over there has to be a minus because it comes from here. Right? And this was determined by someone else. They did the calculations and worked all of that out. We are just basically using that in order to inform our calculation. All right? And I have a matrix. I want to find, okay, so example. I want to find the determinant of matrix A, which is going to be, okay, and I'm going to use the first row over here, right? One thing you must also note, it doesn't actually matter which column or which row you use. The determinant is always going to be the same. So we're going to use 3 first. So let's circle 3, right? And put a line through there and a line through there, right? The sign of that 3 position is going to be positive, as I showed you up here, see? So that is going to be positive. It's going to be 3 times our minor, which is everything that is not covered by the red. So it's 6, 7, 9, and 2. The next element is this one here, right? The sign of that is negative. So it has to be negative 2. And our minor is going to be everything that is not covered with that blue. So it will be 4 and 7, 2 and 2. The last one is the 5. The sign of the 5 is going to be plus. So it is going to be plus 5, right? And then if we put our lines through again, your minor is going to be everything that is not covered by that yellow. So that would be 4 and 6, 2 and 9. So that is what it's going to be. Remember that these are now just 2 by 2 determinants. Okay? And we remember we find that by saying, let's do it like this. So the first one I'll use is red. So it will be that times that minus that times that. So it will be 6 times 2 minus 9 times 7. All right. The next one, which is our blue one, is going to be that. Oops, that times that minus that times that. So minus 2 times 4 times 2 minus 7 times 2. Okay, let's just move this over a little bit so we can see. And then we've got the yellow one, which is going to be that times that minus that times that. So plus 5 4 times 9 minus 2 times 6. Okay, and that is going to work out to minus 21. Now, if you see, you'll find that if you use the first column, for example, so let me just rewrite this. So say, for example, you can try this for yourself. I'm not going to go through this again. So 2, 5, 4, 2, 6, 7, 9, and 2. Right, so say you use the first column. So my first red one is going to be this one, right? Multiplied by the minor, right? Which will be that over there. The second one is going to be the 4. And you go through the same procedure as you did the first time. Right? Like that and that. And you go through the same calculation. You will find that the determinant of A, if you use A 1 times the minor, and this is going to be minus A 2 times the minor, plus a 3 times the minor, is also going to equal to minus 21. So it doesn't matter which row or which column you use in order to find your determinant, you are always going to come out with the same number. If you work with a 4 by 4, 5 by 5, you're always going to end up, you have to go through the same calculation, should I say. So you can see that this is becoming extremely big and complicated, right? Like with all matrices, and that's why, again, we use software in order to find these things. But it gives you a good idea of how a determinant is found. So we're going to be using this in a later video in order to find the solution of simultaneous equations. And I will see you then. Hopefully this was interesting to you. If you have any kind of comments, if there are things that I missed or I need to add, please let me know. And I will see you next time. Bye.